All right, hello, my gems. Today we're going to do our week 2 notes on 9.2, which is all about angles of elevation and depression and some double triangle trig problems. So last week, you guys should have taken notes on regular trigonometry with right triangles, right? So that was the sine, cosine, and tangent. Today, we're going to do some double triangle trig problems and then essentially some word problems. So you're going to watch the video, you're going to take these notes. When you're done, you're going to complete a worksheet that's a 9.2 practice worksheet, and you're going to check your answers with mine on Canvas. There is not going to be any IXLs this week because there are no word problems on IXL. And the practice itself is not going to be graded, but I'm going to highly suggest that you attempt it and do it without looking at the answers on Canvas, because when you go to take your quiz at the end of the week, it does look exactly the same. So it's just some good practice to make sure you understand it before you get to the quiz. Okay, so let's get started with our double triangle trig problems. So in these problems, what you're going to see is you've got two right triangles that are going to share a side, or they have one side in common. And we're going to either figure out a side length or an angle using our trigonometry. Remember that last week we learned SOHCAHTOA, which was sine, cosine, and tangent. And remember, we use regular sine, cosine, tangent when we're trying to find a side length, and then we use the inverse, the ones with the -1s, when we're trying to find an angle measure. So in number 1, we're trying to find the measure of angle C, and we're going to round our answer to the nearest degree. So we are looking for this angle over here. This is our general question. Now, first thing that I notice is if I try to jump right over here to this problem, I only have one side length over here. I don't have anything else. So it's going to be really hard to jump right over there to that problem. So we're going to jump over here to the left problem because there's more information here. Now, first thing that we do is we just determine which side these two triangles share or have in common. So if we look at this picture, triangle ABD and triangle CBD both have this side BD in common. So that means when they're together, that side should be the same. And if I were to separate them into two separate triangles, this side should still be exactly the same for both. So we're going to start by finding that shared side. And so our shared side is BD. So that's what we're going to try to start by finding, our shared side. Okay, now, that being said, I'm going to look just at the triangle on the left because this one has more information. So that's going to be the triangle that I use when I go to do my trig problem here. So what I'm going to do is I'm going to just redraw this triangle out on the left by itself, just kind of separate it so it just looks a little bit easier as I go to do the problem, so that I don't confuse myself. So this is 56. This one's 12.6 centimeters. And then this is the side I'm looking for, BD, right over here. So just like a regular trig problem like we did before, we're going to start by labeling our sides. So here's my 90 degrees. My hypotenuse is across from the 90. There's nothing there. If 56 is my reference angle, across from it or opposite would be my side BD. And then the 12.6 is going to be my adjacent side. It's right next to the 56. So if I'm going to use opposite and adjacent, I'm going to use tangent for my problem. So my setup for this is tan of my reference angle, and my reference angle is 56 degrees. So tan 56 equals opposite over adjacent. So opposite, I don't know. You can put an X there if you want. I'm just going to leave it as BD for that side. Over adjacent is 12.6. Okay. And now I'm going to turn the first one into a fraction by putting a 1 underneath it. And then I'm just going to cross multiply. So BD times 1 or X times 1, whatever, that's just going to stay as BD. That's the side I'm looking for. All I really have to do is multiply the tangent of 56 times 12.6. So I'm going to plug that into my calculator now. And remember, when you go to plug into your calculator, you always want to push the number before you push the trig function. So I'm going to push 56 tan and then times 12.6. So 18.7 is fine, and that is going to be my length of BD, is 18.7. So I'm going to come over here to my picture and I'm going to plug in 18.7 on that side that I just found. Now that I have this side and I have a second side over here, I can now figure out what angle C is. So now I'm going to look just at the triangle on the right. And again, I'm going to redraw it over here individually to kind of help myself out. So I know that this side across from the 90 is 22.5. I know this side BD, that's what I just solved for. That's the 18.7. So I'm plugging in my answer there. And I'm trying to figure out this angle C right here. So that's what I'm trying to determine. Now, just like before, I'm going to start by labeling my sides. So my hypotenuse is across from the 90. And then if C is my reference angle, the 18.7 is across from it. So this is my opposite side. So if I'm going to use opposite and hypotenuse, my choice is going to be sine. Now, because I'm looking for an angle this time, I'm going to use the inverse sine because I don't know what the angle is. So the inverse sine equals opposite over hypotenuse is 18.7 over 22.5. And now it's just a plug and chug into my calculator. So when I go to plug this in, I'm going to push the fraction first. 18.7 divided by 22.5 equals, get it as a decimal, and then I push shift sign, or in my case on my phone, second sign. And my answer is about 56.2 degrees. It asks me to round to the nearest whole number, the nearest degree. So I'm just going to put angle C is equal to 56 degrees. And you've just done a double trig problem. So we always start by finding the shared side first. And then once we have our shared side, we plug our information in and we move on to the next one. Okay, number 2 says, find the measure of side length B, round your answer to the nearest tenth. So again, I see this as a double trig problem. So I'm going to start by solving for the side that they have in common. The side that they have in common is this center side right here. So this is the side I want to do first. Now, between the two triangles, I see that the triangle on the left has more information. So that's going to be the side that I start with. I'm going to start with this pink one. Okay, so again, I'm just going to redraw the triangle. I like to keep myself really organized here so that I don't mess up. Okay, and this over here, this question mark, that's going to be the side that I am looking for. So just like before, I'm going to start by labeling my sides. If the 51 is my reference angle, across from the 90, my question mark is my hypotenuse. And then the 10 is opposite the 51 or across from it. So this is my opposite side. Opposite and hypotenuse uses sine. So my ratio is going to be sine of 51 equals opposite over hypotenuse is 10 over, put question mark, or I'm just going to put an X there. Okay, put a 1 underneath, and now I cross multiply. 10 times 1 is 10, equals sine of 51 times X is sine of 51 times X. Now to get the X by itself, because it's not alone right now, is I need to get rid of the sine of 51. And because this is multiplication, to undo that, I'm going to divide both sides by sine of 51. And so now I just plug it into my calculator. So when I plug it in, I put 10 divided by 51 sine equals, and I get about 12.9. So this side length here is 12.9. That's the shared side. So I'm going to come to my picture and I'm going to put in a 12.9 right there. Now I take a look at my second triangle, which is this one on the right. And again, I'm going to redraw this picture separately. You don't have to, but again, I like to personally. I'm going to label what I have. I've got the 55 degrees, and then I want to make sure I put in that shared side that I just determined, which was 12.9. Okay, and now we're finding another side length this time. So again, I do the same thing. My hypotenuse is across from the 90, so that's the B. And then the 12.9 is across from the 55, so this is opposite. Opposite and hypotenuse, again, is going to be the sine. And so I write it as sine of my reference angle. So sine of 55 equals opposite over hypotenuse is 12.9 over B. Now, again, I can go through and I can cross multiply, but I'm going to kind of give you a little bit of a trick here. So in the first problem, notice that when my number is at the bottom and my variable was at the top, all I had to do was multiply these two numbers. When in the second problem, when the variable is at the bottom, I'm really dividing these two numbers. So I already see that my variable is at the bottom. That means what I'm going to have to do is I'm going to have to divide these two numbers. So I'm going to take 12.9 and divide it by sine of 55. If you like that little trick, you can use it. If not, and you want to just continue to cross multiply, you are welcome to do that as well. Okay, so now I just plug it into my calculator. 12.9 divided by, and then I always put 55 sine equals, oops, oh no, I pressed it twice, sorry. 55 sine equals, my answer is 15.7. So length B is 15.7. So double trig problems are essentially, you just have to do a trig problem 2 times and you take your first answer and you're going to have to plug it in to use it for your second answer. Now, part 2 is all about angles of elevation and angles of depression. So when we get to word problems here, you're going to start seeing some, instead of just giving you a picture, I'm going to start talking about the angles, the reference angles as elevation or depression. An angle of elevation means you are at the bottom and you are looking up to an object. So angle of elevation means you literally have to take your head and elevate it or push it upwards. If you're pushing it up, right, like if you wanted to see the height of something, like how tall the school is, obviously you'd be on the ground looking up. So angle of elevation is formed by an observer's line of sight and a horizontal line. It's always at the bottom here. Okay, so neutral is just your head straight forward, but then elevation means you literally lift your head up. Angle of depression is just the opposite. When looking down on an object, the angle of depression is formed by an observer's line of sight and the horizontal line. So again, if you look straight out, that's just neutral. But if you tilt your head down, that means it's an angle of depression. You're looking down. That angle is on the outside of a triangle. However, the angle of depression is congruent to your angle of elevation because these are alternate interior angles, right? So here's your parallel lines. These are alternate interior angles. And this should kind of make sense. So think about it like this. If I was standing at the top of the school and somebody in the class was standing at the bottom of the school and we were trying to look at each other, in a perfect world, what that means is when I'm up at the top of the school, I have to tilt my head down a certain number of degrees. The person at the bottom should tilt their head up the same amount so that we can kind of meet each other and look at each other. So angle of elevation and depression should be congruent. All right, so let's do some word problems. From the top of a vertical cliff 42 meters high, the angle of depression to the beach is 34 degrees. How far is the beach from the base of the cliff? So I'm going to draw, we always start by drawing a right triangle because all of these are right triangles. And then we are going to add in our info from here. So we're at the top of a vertical cliff and the cliff itself is 42 meters high. So this is your cliff up here. This is 42 meters. Now that means you're standing up here at the top of the cliff. It says the angle of depression to the beach is 34 degrees. So that means the beach is down here. Gorgeous, what a drawing. Depression means you are looking, if you were looking directly out, depression means you have to tilt your head down. So this angle on the outside right here is 34 degrees. I want to know how far is the beach from the base of the cliff. So base is the bottom of the cliff. So here's the bottom of the cliff. And I want to know how far it is from the beach. This is the side I'm looking for. Now, this angle of depression is exactly the same. Its alternate interior angle is right over here. So this one is also 34 degrees. Now, this is just a regular trig problem. And so we label our sides. So I don't have a height because there's nothing across from the 90. If this one down here, this 34 at the bottom, this is my reference angle down here. The opposite side is the one across, so that would be the 42. That's my op. And then the X is next to the 34, so this is adjacent. Opposite and adjacent uses tangent. So tan of my reference angle, so tan of 34 equals op over adjacent, which is 42 over X. And then I cross multiply. Again, though, I'm going to cut it short because the X is at the bottom. I know I have to divide my two numbers. And now we plug it into our calculators. So when we plug it in, we do 42 divided by 34 tan, and then we push equals. So the beach is 62.3 meters away. That's the distance over here. So hopefully you're noticing it's really not that bad. I mean, it's pretty much exactly like a regular trig problem, but you do have to draw the picture yourself. Okay, number 4. Mr. Masso's kite is flying above a field at the end of a 65-meter of string. The angle of elevation to the kite measures 70 degrees, and Mr. Masso is holding the kite 1.2 meters off the ground. How high above the ground is the kite flying? So we're going to start again with our right triangle. Okay, Mr. Masso's kite is flying above a field, so obviously my kite is up at the top. There's my kite. Now, if Mr. Masso is holding the string, you have to think when you're holding a kite, it's not vertical up and down. When you hold a kite, it's kind of like diagonal, right? Because the wind blows a little bit. So Mr. Masso is really down over here on the right, holding that kite up. It says my angle, or sorry, so it says the string is 65 meters long. So the string is where I'm connected to the kite. So this side over here is my 65 meters. It also says my angle of elevation to the kite is 70 degrees. So elevation means I'm at the bottom and I'm looking up at my kite. So elevation is 70 degrees, is down at the bottom here. It also says Mr. Masso is holding the kite 1.2 meters off the ground. So that means it's not on the floor, right? It's additionally, it's an additional 1.2 meters off the ground. So my height essentially of where I'm holding it is 1.2 meters. I want to know how high above the ground is the kite flying. So I want to know what the height is of my kite. So this is the height I'm looking for. Now, I'm going to find this height using regular trig, but then the trick here is I'm an additional 1.2 meters off the ground. So after I find this height, I'm going to add in the 1.2 because that's an additional height up off the ground. Okay, so I label my sides just like we did before. 70 is my reference angle. X is opposite, and 65 is the height. So opposite and hypotenuse uses sine. So sine of 70 degrees equals X over 65. Because X is at the top, when I go to cross multiply, all I have to do is multiply the sine of 70 times 65, and that's going to give me my answer for X. So we put it in our calculators by doing 70 sine and then times 65. We get 61 point, we'll put 61.1. 61.1. Now that's the height from where I'm holding it up to the top of the kite. But then remember, I'm an additional 1.2 meters off the ground. So I have to add 1.2 to get my total height. So my total height is 62.3 meters. Okay, so anytime you see an additional height off the ground, you're going to have to add that height in, hence the word addition, right? Additional, crazy. All right, almost done. Number 5. from a plane flying at 265 meters above sea level, the angles of depression of two ships sailing east measure 35 and 25 degrees. How far apart are the ships? Okay. So again, we're going to start with a right triangle. So it says my airplane is flying 265 meters above the sea. So here's the sea. Here's my airplane. Wow, I'm an artist. Oh my gosh. It's flying 265 meters above the sea. So this side on the left here is 265. There's my height. And it says the angles of depression of two ships sailing east measure 35 degrees and 25 degrees. So depression means if I was looking directly out, right, going down are going to be my angles of depression. Now, when I look down right here, this only gets me to my first ship, but there are two ships. So I have another angle of depression looking down. So it's like a two like right triangles. You've got this smaller one here, and then you've got this larger one over here. Now, one of my angles of depression is 35 and one is 25. Now think about this. If you're, and I don't know if you can see my head, but if you are looking down at a 25, that means you're moving your head just a little bit down. And then if you're moving it 35, that means you're moving it even further down. So the smaller depression angle is going to be the first one here. This one is 25 degrees. And then if you go further to the second one, that's all the way down to here, this one's going to be 35 degrees. Now, angles of depression are congruent to their angles of elevation. So if this angle out here is 25, then alternate interior, this one's also 25. If this angle's 35, alternate interior, this angle is also 35. So I want to know what the distance is between these two ships. So I need to figure out what this space is right here between these two. So what I'm going to do is I'm going to look at these as two separate triangles. I'm going to look at just the triangle over here on the left. And I'm just going to figure out what's the distance here at the bottom from where the plane is to the ship. I'm just going to start with that one. So I'm going to come and draw my first triangle off over here. Notice this is kind of like the other problems we've done. We're kind of separating our triangles. I'm just going to call this side X. All right, so we're going to figure out what the distance is from where the ship was to the 35 degrees. So if I label my sides, 265 is across from the 35, so this is opposite. And X is next to the 35, so this is adjacent. So off and adjacent uses tangent. So tan of 35 equals op over adjacent, 265 over X. Because X is at the bottom, we are going to divide these two numbers. I'm going to do that by plugging it into my calculator. So 265 divided by 35 tan equals about 378.5. So the first distance right here from the edge to the first ship is 378.5 meters. That's the first one. Now we're going to do the same idea for the second triangle. Now, this little piece over here is not the second triangle. The second triangle is, again, from where the plane is all the way to the edge over here. So it's a much bigger triangle now. And again, I'm just going to label what I've got. So again, I know the height is still 265. And I know my angle this time is 25. And again, I'm trying to find this bottom length from the edge all the way over here to the ship. And so I'm going to call this side Y this time. Now, just like the last one, I'm just going to label the sides. So if 25 is my reference angle, Across from it is the 265, that's op. And next to the 265 is adjacent. This one is again opposite and adjacent, which is tan. So tan 25 equals opposite 265 over adjacent. Y. Notice it's almost exactly the same setup. So because y is at the bottom, we're going to divide these two numbers. $265 divided by 25 tan equals. So this distance is 568.3 meters. Now, the first distance right here from the from where the plane is to the first ship, this was 378 meters. The distance from the plane to the second ship was 568 meters, but I just want this little sliver right here. So what I'm going to do is I'm going to take the whole thing and I'm going to subtract the pink piece, and that's going to leave me with what's left over, the distance between the two. So to get my final answer, my distance, I'm going to take 568.3 and subtract 378.5. So my total distance is 189.8 meters. That is the distance between the two ships. Okay. So you're definitely going to see ones like that on both your practice and on your quiz. Cough, cough, and hint, a wink, a wink. All right, two more, then we're done. Number 6. In the figure, SN is a Christmas tree right here. P and Q are 2 points on the horizontal ground. The angles of elevation of S from P and Q are 37 degrees and 52 degrees respectively, excuse me. If S and P are 26 meters apart, find the distance between N and Q. Now, while this looks like a crazy word problem, it's essentially just another double trig problem. I've got two right triangles. I've got one on the left. I've got one on the right. And I'm trying to figure out what this distance is over here. But because I've got two triangles, I already know from all the other ones we've done, I'm going to have to look for their shared side. So if I'm looking between these two triangles, here's my left one. Here's my right one. The shared side, or the side that they have in common, is this side SN. So that's what we're going to start by determining. And then I choose to use the triangle that has more information. The triangle on the left has more numbers, so that's going to be the one that I start with. So our shared side is SN, and that's where I'm going to start. So I'm going to draw out my triangle. Hopefully you notice that I've kind of got like a system here where I always redraw my triangles out. And I would suggest you do the same. Okay, so I'm trying to find this side, SN. So we're going to label the sides. Hypotenuse is across from 90. So across from 90 is my 26. There's my height. And then the question mark is across from the 37. So this is my op. So opposite and hypotenuse use sine. And because we're looking for a side length, I just do regular sine. Sine 37 equals op over height, which is op is SN over height is 26. Because the variable's on top, all I have to do is multiply these two numbers. So I'm just going to plug it into my calculator. So 37 sine times 26. So side SN is 15.6. Now I'm going to take that answer and I'm going to plug it into my picture. And now I'm going to look at the green triangle, excuse me, and I'm going to do the same thing. So in the green triangle, I know that my angle Q is 52. I know this opposite side over here is 15.6 because that's what I just figured out. And I'm trying to find the distance between N and Q. So that's this bottom length right here. So that's my question mark. Okay, so I label my sides. Across from the 90 is the height, but there's no height. So across from the 52 is my opposite. And next to the 52, my question mark is the adjacent. Op and adjacent uses tangent. So tan of my angle 52 equals op over adjacent. So 15.6 over the side I'm looking for, NQ. Now, because my variable is at the bottom, I'm going to have to divide these two numbers. So I'm going to do 15.6 divided by tan of 52. I'm going to plug it into my calculator. And then whatever I get is going to be my final answer. So I plug it in as, 15.6 divided by 52 tan equals. And my final answer is about 12.2 meters. And we're done. So notice that even these word problems are just essentially double trig problems where you solve for the shared side first, and then you move on from there. Okay, last one. Number 7. In the figure, the height of a hill, PN right here, is 760 meters. X and Y represent two banks of a river. N, X, and Y are all on the same horizontal line. The angles of depression of X and Y are 38 and 29 degrees respectively. So there's my angles of depression right over here. They're looking down. What is the distance of the river XY? So I want to know what the distance is between these two. So this one looks almost exactly the same as number 5, where we're going to separate them into two triangles and we're going to find the remaining distance by subtracting our two answers. So first thing I'm going to do though, is I'm going to make sure that my angles of elevation are marked in the picture as well. Oops, wrong way. Because I've got the, so here's my first triangle, P and X. There's my first triangle. And that one matches up with it's the larger angle of depression, right? Because you're moving your head even more. So this one's 38. So my angle X is also going to be 38. And then I'm going to do the same for my large triangle, my green one, which notice is kind of overlapping. And that angle of elevation is going to match with this one, which is 29 degrees. Okay, so we want to figure out these bottom lengths of them, and then we're going to subtract the two. We're going to take the bigger one and subtract it from the smaller one. So I'm just going to, like I did before, I'm going to redraw my picture. Hopefully you're noticing it's like very repetitive, but if you can get the like steps down, then they all pretty much look the same. 760. Okay, so we're trying to find, again, we want to know what the length is at the bottom here because we're trying to find the distance between the pink one and the green one here. We're trying to find just this remaining piece right here. So we're going to solve for this bottom piece over here. So across from my 90 is the height. There's nothing there. I go to my angle of my reference angle. Across from it is 760. That's my op. And next to it is my adjacent. Op and adjacent are tangent. So my first equation is tan of 38, my reference angle, equals op over adjacent is 760 over, I'm going to put nx, that's the side length, nx. Okay, my variable's at the bottom, so I have to divide. So I'll do 760 divided by tan of 38. And all I have to do from here is plug it into my calculator. So 760 divided by 38 tan equals my first distance right here from N to X is 972.8. So that's right here. Yes, that's from this piece to this piece. It's my first one. Now I have to do the same thing for my green triangle. Again, I'm drawing them separately. So I've got this angle down here is 29 degrees, my reference angle. This side is still 760, that hasn't changed. And now I'm trying to find this distance here, which is N from N to Y. That's the distance I'm looking for. So I don't have a height because there's nothing from across from the 90. Across from the 29 is the 760, which is my op. And then next to it is my, next to it is my adjacent, which is next to the 29, the side I'm looking for. So opposite and adjacent, again, is going to use a tangent. So tan of 29 degrees equals op over adjacent, so 760 over NY. Again, since the unknown is at the bottom, I'm going to have to divide these two. So NY equals 760 divided by tan of 29. And again, I just plug that into my calculator. So 760 divided by 29 tan equals, so the full distance from N to Y was 1,371.1 meters. So that's the full length here, that big 1,000 number. So we want to know just what's left over, the distance between the two. So to find that final distance between the two, I'm going to take my larger one, the green one, and I'm going to subtract the pink piece, and that's going to leave me with whatever's left over here to be my my river. So my total distance is going to be 1,371.1 minus 972.8. So my final answer is 398.3 meters. And now we're done. So those were your notes for section 9.2. You're now going to, from the sub or whoever's there, you're now going to get the paper that says week 2, 9.2 practice. And I don't want to show you what it looks like, but it's essentially literally looks, you're going to see it looks exactly the same. Okay. So I'm going to post the answers to this practice, but like when I say it looks the same, I literally mean they should match up almost exactly. I'm going to put the answers to that on Canvas for you. I'd like you to try the practice problems without looking at the answers. And then once you feel really good and really confident, if you get all of them correct, then you can move on to the Canvas quiz, which will include double triangle problems and angles of elevation and depression problems. Okay. Remember, there's no IXL this time around, only because there's no IXLs about this. So you're just doing the worksheet. Okay. So if you have any questions, remember to just come down to me at the end of the hall. You can come during lunch, and hopefully this was helpful for you. And after this section, we only have one chapter left. So that's really exciting. Okay. Go ahead and get going on your practice. Okay, bye.